Hey guys, I guess we'll just go ahead and get started today. Welcome to another Common Lisp study group, folks. This is Ron Badham from Atlanta Functional Programming coming to you live. Today we'll be discussing ASDF, the build system, the de facto build system specifically of Common Lisp to be used to create your Common Lisp libraries, modules, and/or applications. The agenda that I have is I'm going to really give you an overview, initial overview of ASDF, and in particular how to build a system with ASDF, how to install software with ASDF, specifically via the Quick Lisp utility, and we will do a small segue into Quick Lisp primarily to give differences between what their roles and responsibilities are. To start things off a little bit, I'd like to at least begin by talking about what it means by bundling Lisp code. Compared to other languages, say for example C++, or even C, or other compiled languages such as Go, Rust, and so on. Lisp gives you the ability to provide compiled code, particularly a facile code that allow you to load libraries, much like shared libraries, into your Lisp image. As well, it gives you the opportunity to also provide source code that people can then compile separately themselves and then load directly into their Lisp image. This, in turn, somewhat complicates the responsibilities of a particular utility that should be able to do those kinds of tasks. If you look at the compiled language world, particularly the C or Java or C++ world, there were tools that were built specifically for the building of these types of libraries and applications. In particular, in the C++ world, there are a plethora of tools, starting with the most classical one, GNU Make, and/or CMake, coming out of the folks at Kitware, who make the ITK image segmentation toolkit, as well as Premake 4 that was written in Lua, or even Visual Studio's MS Build XML schema for you to define your build system. In the Lisp world, this was more of a recent development, primarily in the last 15 years. There were commercial solutions that gave you the ability to create commercial Lisp applications, and there were ways for you to bundle your Lisp code and scripts that were normally written in conjunction with the operating system. But really, it wasn't until, I would say, until ASDF was created that there was a standardized way across multiple Lisps to actually do this. So this is kind of obviously a nice thing. So now, regardless of what Lisp you actually use, ASDF would be available for you to be able to compile and load your systems in a cross Lisp manner. So what does ASDF actually stand for? ASDF stands for Another System Definition Utility. The reason it was defined this way is because LispWorks and some others actually created a concept of definitions, and I think there was actually some papers out in the early days that talked about the design of large systems, off of which ASDF was sort of inspired by some of the design decisions or design suggestions that were built on those papers. I will go ahead and provide a link or a couple of resources related to that information later on. It is a tool specifically to design not only Common Lisp applications, but Common Lisp libraries. And you can build these libraries in a particular way. You define what's called a build specification, where you order your dependencies, you order your modules, And what it does ultimately is when you type in or load up a library, say like you load up Alexandria, what and I won't use Quick Lisp for the time being. Instead, I'll actually load it the way you would normally use if you just used ASDF itself. What it would do is and it will behind the scenes check to see if Alexandria is first off compiled, and if it is, it will automatically load it into your Lisp image. Now, ASDF in this way provides a couple of options, and this is just for using libraries. We're not even talking about creating your own libraries or creating your own systems. You can actually go and recompile libraries that you have already installed inside your computer, inside the standard what ASDF calls the source registry. Now, where is the source registry actually located? The source registry is typically in, and this is their recommended place. Of course, you could change it, although I will point out that if you're using Quick Lisp or other ones, and this we will touch base on later on, there are standardized locations where they expect your systems to be available because that's where they're downloaded to. Quick Lisp particularly installs it in what's called the Quick Lisp's dis directory, which stands for distributions, and you can actually go and look in there to see all the source software that you've actually downloaded from their curated repository that's up on AWS S3. But if you're not using Quick Lisp, normally the suggested location is in $home/Common Lisp, and this is of course using Unix syntax. That's basically your home directory. And there will be a directory called Common Lisp there, and that's where your definitions will be available. Those are usually defined in directories with the combination of the source code. Either has FASL files or the actual open source Lisp files themselves, and a special file that's called an ASD file, which literally stands for another system definition file. And we have an example displayed for you, and we will discuss the syntax in a little bit. But what I want to at least convey here at the start is these system definition files, first off, start out when you're loading with Common Lisp and you're loading the library with essentially the state of the Lisp image at the time of the library load. So if you can think of, let's say that you start up SBCL and you want to use Alexandria always, and there are ways that you can do this. What happens is SBCL first loads up a vanilla Lisp image, a vanilla Lisp process. It starts everything up. Then it will invoke essentially ASDF operate on system, and it calls a function called ASDF loadop. And we'll talk about what these enums, well, these operation objects are in a second. But it takes that and essentially looks for the system in the source registry, and it will, if it wasn't compiled, it'll compile it into FASLs and then load up the FASLs into your Lisp process. Okay, so this is a way that you can actually reproduce and somewhat reliably load up your Lisp libraries. Now, this is, I say somewhat reliably, primarily because, if particular system definitions were written in a way that, well, in particular packages, if they were written in a way that certain names were just directly exported into, like, CL user or the package that you're actually using, you might hit a situation where there are, like, name conflicts. But that's really a caused by how the packages were written or how and how it was actually being compiled, not actually a function of the build system having an issue. So in this respect, ASDF is very much in line with existing build systems for commonly compiled languages like C, C++, or Java, or whatnot. So you must think of this primarily like Make or Ant or Maven, where you define your dependencies. It won't download them. It will actually search for them inside your source registry, and if it doesn't exist, it will complain. And it will go ahead, and if they do exist, it will compile them and then load them in the fashion that you'd like them to be. So this leads me to tell you what exactly ASDF is not. All right. ASDF is most definitely not a package manager for Common Lisp. It is a build system. It is a tool to build your code. It is a tool to specify how to build your code, what dependencies your code needs to have available at load time when it's actually going to start operating on it and compiling it and loading it into your process. And things have changed. So for those of you who are on this stream, we're probably going to be asking about things like ASDF 2 versus ASDF 3. I'm just going to be upfront. We are only talking about ASDF 3 here today. We will not be discussing the earlier versions at all. A lot of that has been deprecated. If you want to know the differences between what is in ASDF 2 and ASDF 3, I strongly encourage you to go look at the ASDF manual that's available at commonlisp.net/ASDF, and I'll go ahead and post a link on that along with this sample project that I've created for you guys to actually look at and get some ideas or even build off of. Are there any questions? So where does then ASDF fit in the current Common Lisp ecosystem? Like, since it is not a package manager, it's just a build system. Well, you start with your Lisp code, and usually you will use ASDF to define your build file, your make file. And if you are building up a library, what you would normally do is you would prepare it for Quick Lisp by just specifying a couple of things. So let's take an example here that I've just built for today, and we will go through this. This is somewhat of a complex but still contrived example of a program, and I'm talking about a standalone executable program that one might build with ASDF. Okay, and all it does is simply, and I'll show you later what the Lisp code does, but this is just a standalone executable program that will print something out. Now, at the start of every definition file, ASDF definition file, you can have as much comments as you want. I'm obviously using as many comments as I want. But the main thing to look at is the start of a definition is always on something called def system. Def system takes in a string that represents your system designator. And it has a bunch of metadata that you'll normally attach to it. In particular, if you are going to set this up as a library situation, you'd want these four keys defined for your system, and that is the description, which are a small description as to what the project is about, the version number, and something about the version number I'm going to just mainly point out here, and we'll go into much more detail a little bit later. It is always in this format, and that is a period separated string. There are ways for you to get this information in here through like read forms, but the bottom line is the output of that is always going to be something of this form, which is major version, minor version, and patch. Obviously, you need to specify the point of contact of the library and what license the library is going to be adhering to. This is specifically, these 4 values, description, version, author, and license, are required if you're intending to include this software library in Quick Lisp. The documentation actually says strongly recommended, but from what I've been seeing, at least, when you do an apropos on all the search results inside Quick Lisp itself, these values almost always show up. Additionally, if you are using third-party libraries, let's say in this case we are using Alexandria, you would use something called depends on to actually specify a list of third-party dependencies and these are essentially dependencies that are required to be loaded prior to your code to being compiled. So it's expecting them to be there. Those symbols have to be there. They've probably been pre-parsed and whatever. After that, then we have a little bit more flexibility. So I'm going to go ahead and first show you what you could do. So let's take out these two values first. Components in your base system essentially is listing a set of components. Now, a component is essentially just an object that represents a source file or a group of source files, or it could be something else. Later on, I'll show you that ASDF actually provides a API that allows you to extend these base things. If you look at the documentation specifically, the 4 types of components are file, module. Module represents basically a directory that contains multiple files. Static file, which is really like an asset, like if you have, like, say, a text file that requires to be present inside the directory and must be available so that you can actually compile the code. That is something that you would obviously specify in your system definition. And you have something called a component type. The component type is basically a user-defined type. You can actually extend the types of components that are read in by ASDF and used to build your code. Now, when you write your code this way and not specify the order in which the code is actually dependent on and that is loaded, Common Lisp will try to load them in parallel. It will try to compile them in parallel, and it will cause complaints, especially if you're particularly looking for a symbol, for example, and it doesn't exist. Now, there are 2 ways to actually prevent that from happening. One way is using what's called depends on. This is basically telling ASDF, and specifically the Lisp process, that this file must have been loaded prior to before I have actually compiled this module. So in this case, we're telling ASDF and Common Lisp that packages must be loaded prior to you actually loading utils. Now, you have to actually do the depends on when you're using modules always, but when you're using files, you also have the ability to use depends on as well. So here, we can actually say we are using utils prior to actually, so we must have utils loaded prior to actually loading up hello. I'm sure a couple of you have already noticed that the file has just packages, but does not indicate what is the extension. By default, ASDF expects the extension for all Lisp source code to be .lisp. I think I read somewhere there's a way to change this, but I don't recommend you doing it. I know some people who use like commercial Lisps do it just because they have years of Lisp code that was saved off as .cl. But nowadays, in 2018, almost all but every major Common Lisp implementation uses the .lisp extension, as far as I know. Unless you really have some legacy code, don't bother changing the. Don't specify. You don't need to specify the extension. Instead of using depends on, what I had earlier, which some of you may have saw, was this thing called serial. Serial basically tells ASDF that the component's definition, the order the component's definition is in, is the order that it should be loaded in. So it'll just basically do the car of this list, and then they'll just keep going through or loading each of them one at a time. Concept about modules. Modules, as you know, is essentially a group of source files on the file system. And I'm going to show this to you because I think it's probably easier to. Sure. Yes. Okay. So if you look at our directory here, you will notice that utils is an actual. This is actually I should have. I think I should. You will see that utils is an actual directory that contains a file called utils.lisp. This utils.lisp just defines a function that we're using in our hello program. And I'll go ahead and do a bit of a code walkthrough here. But what I was trying to show you is when you're defining directories inside your system definition, module essentially expects them to be that way. They are when you're using the :module keyword to say that something is a module, the ASDF library expects that that name that you're using specifies a path name, a relative path name, to a directory, and that directory will contain multiple components. So this example here, while definitely doesn't even scratch the surface as to what is actually available, does provide essentially enough for you to load up an ASDF system and actually even build it. If you're, for example, not building an executable, you're making a library, you don't need, for example, entry point. Entry point is basically saying which function in my image is my top level. It's like the equivalent of main. And it will go ahead and bind that and make a function call when if you're making a standalone executable to call that function. So if you're making a library, you don't need this. So this is what would a typical library have defined. Description, version, author, license. Depends on will tell you what third-party dependencies you're using. Normally, at least this is what I use on a day-to-day basis. I use the serial keyword to say that I'm doing an in-order loading of each file, and then I specify an ordered list of the files or directories based on how they're dependent upon each other. This way, it's easier to just look at it and read what the order of the loading is, and you can sort of use that for debugging. So we've defined this. How do we actually go ahead and use this? The way we would use this, as I showed you earlier, is through a function called load system. Now, Common Lisp has a couple of ASDF has a couple of functions, convenience functions, built for you to do your normal day-to-day, loading and compiling and reloading of systems. One is obviously compile system. Compile system, all it does is it takes in a string which represents the name of the thing that you're the system that you're trying to compile, obviously that's a directory that holds an ASD file. And if you run this, it'll go ahead and compile through the code, check to see if any dependencies need to be compiled, and get them loaded, and then go ahead and compile those recursively. Now, if you want a full recompile including your dependencies, so in this case, you notice that I'm using Alexandria, all right? If I want to say, hey, Common Lisp, I want you to actually compile the system completely, including all dependencies, what we'd use is something called force. And force has two options. If you want to recompile, let's say, your current module, all right, just hello ASDF, right, which is our system, but not its third-party dependencies. You just specify true, it'll recompile hello ASDF. We're actually good. And you'll notice that if you try to compile this without it, it won't actually compile it. So you have to actually use force. If you want to compile everything, you do force : all. And what it does is it will go through and compile Alexandria, then it will compile my utilities module, and then it will finally compile the hello package, and then it'll spit out, hey, we're good. It'll spit out a FASL. There are other actual equivalent functions like that, like load system essentially works the same way. It'll try and recompile everything. They have something called make that does the same thing. It's and if you actually look at each of the signatures, and let's do that. Can you guys see my mini buffer at all?
Yep.
Okay.
Yes.
So if you look at compile system, load system, or even require system, it's the same thing actually. It has force, force not, it has verbose, and it has the version. The version allows you to actually specify its explicit version that you want to actually load in. So you can tar up different versions, as you can see, inside your own source directory, and it will actually go in, look into the source directory, and say, okay, I want to use 0.002 of hello ASDF instead of 0.001, and it'll go recompile that guy and load it into your system. This actually gives you the ability to work with multiple versions of software, which are at various stages of development. Do I recommend it? I try to stay as consistent with QuickLisp and what versions it has, just so that I can safely provide somebody an ASD file, and they can just do a vanilla build of everything and get what is available on AWS. Now, I don't know how others use ASDF in this particular respect, but this is at least how I do it. Michael Fiano, I know you're one of the more senior Lispers here. Do you try to stray away from QuickLisp, and in what situations do you stray away from QuickLisp? When you
I pretty much recommend using QuickLisp instead of ASDF explicitly.
Okay.
I do the same pretty much, except for rare circumstances.
Excellent. So this is basically a simple example of ASDF in action. But why am I showing you ASDF in vanilla mode? As Michael pointed out earlier, we normally use QuickLisp. I wanted to show you a couple of interesting things that that's available at your disposal if you just out of the box with ASDF, separate from some of the more advanced features like UIOp that's available also through the ASDF package, which we will discuss in next week when we start talking about UIOp a little bit. ASDF provides something called an operate call. All right. So what I said earlier about operations, like CompileOp, LoadOp, or even some of the examples that we saw with load system, for example. What these guys do is they actually call a much more lower level operation called operate that allows you to specify a specific build step and call it on a particular system. So let me rewind a little bit and tell you what exactly ASDF does when it reads in a system definition to get to this particular example. When ASDF first starts out running a particular operation, it reads in your system definition and builds what is called a build chain. All right, and it's an operation chain where the key is the operation that it needs to execute on, and then the value is the actual system that it's going to execute on itself. So if you wanted to see something like this, and you can actually certainly do this, and it kind of helps when you're trying to figure out what exactly where something is failing. And this is only, I do recommend only doing this when you're debugging. You don't try to do this on a day-to-day basis. You can traverse the operation that you want to do and specify the system. And that is through what's called ASDF traverse. Let's say that we want to, say, compile a system. This is what's used by ASDF compile system. And we want to actually build off our package again. And more importantly, we want to actually force recompile it, right? Which means it's compiling everything. What happens in this situation? What happens is we generate a list of all these actions, this action chain, of where it's actually going through and saying, okay, let's prepare the actual systems for compilation and all the static files associated with it. Then let's prepare the actual compilation stage and build it off of it. This action here, CompileOp, actually goes through all the Lisp files and essentially compiles them. And then this LoadOp actually is what's actually taking the symbols from the FASL file, which is the fast assembly file that's generated by Common Lisp, and it will load it into your Lisp image. And you could do this for every stage of the process, and ASDF provides a lot of different operations for different stages, and for, like I said, only a fraction of those have been actually exposed as convenience functions, just based on your day-to-day, and I've actually essentially showed you the main ones, which is compile system, load system, and require system. Require system actually does the same thing as what load system, compile system does, but the difference is compile require system does not actually compile third-party dependencies unless you explicitly force it to. It's essentially like using Common Lisp require. It updates. It doesn't update any symbols that are already available at all. So those are your convenience functions. There's also a convenience function for something called test, which gives you the ability to actually create a separate test call, and which brings me to another thing about ASDF. ASDF that can run much like a make test call that will allow you to test your framework or your compilation. However, if you use test system, all right, to run your test suite, you will hit a situation where if you don't actually return like a nil or a true, an infinite loop, at least from what I read in the documentation. All right. So what was suggested is if you are going to do this, is to create a condition on your test suite, or even better, make a separate system that runs your test suite, adding your test framework, like whether you're using Lisp test or 5 a.m. or I'm forgetting Lisp unit. Whatever test framework you're using, you can only specify it in that system so that that's the only place where it's going to get loaded. Make it dependent upon your other library, and then when you run the test suite, add a condition in that system that essentially, if it fails, it will capture the failure, wrap it up in a nice, meaningful error message, and return nil. This again, I need to provide a more complete example for this because I'm only touching base on it right now for just a fair warning for folks who are listening onto this. But our example that I'm showing you does not actually go through and build the test system stuff. So one final thing that I may as well bring up is make. Make actually is what is recommended in at least from the manuals that I've been reading. Make is the actual command that you should use to actually compile and load your systems rather than the other lower level ones, because according to the documentation, starting with the newer versions of ASDF, make tries real hard to do the right thing for the Lisp of your choice. So if you're using SPCL, whatever is needed to actually build and load the systems, it will do correctly. Again, this is if you're using vanilla ASDF, which you may use when you're debugging your system definitions, but it's not necessarily recommended if you use it in vanilla, and we'll segue into Quick Lisp in just a few minutes to actually show how that would actually be leveraged. What I showed you in terms of the metadata piece is not the complete story. There is a lot of metadata that you could provide in your system definition. I've alluded to this with a couple of things here. For example, you could specify what bug tracker you're associating to, who to contact via their email, a long name for the actual package, a very large. You can provide a pretty decent paragraph describing what the project is all about, your source control, URL, and so much more. You can manipulate particular stages of the process and even deal with the output files of the individual stages. Honestly, it depends on what you are trying to actually accomplish with your Lisp system. If you're like me and you're only looking for, say, creating a standalone executable or a static library, you might use only a subset of these things. And I'm going to show you one example, which is with creating an executable. So I have this, so let's go and navigate through this code base here. So I have a project here called Hello ASDF with 3 files, a packages file that if we look at, just defines 2 packages, your utilities package that contains certain things, and it's exporting a particular function for something, and just another package that leverages that utility function. Okay, so nothing major. In our hello, our utils/utils.lisp file, you'll see that we're actually defining some function in this package. I'm pretty sure some who are noticing here, I did not define. I defined the package that the utils directory is defining at the top level. Could I have defined a separate packages directory inside packages.lisp inside that utils directory? Yes, you could. You can actually modify this guy and create a separate packages.lisp inside your utils directory. That, so that way in each directory, you know what packages are actually being defined in that directory level. It's not necessary for you to actually go and do that. But if you do that, obviously you can get rid of this, and you can actually specify inside your components list file packages. So now you have a packages file that defines all the packages in the top level, and a packages file that's defined in the specific module level. Once you have that actually defined, and let's say that we double check, we loaded, everything's actually good. Let's say that you want to go and create an executable. Now, if you look at hello.lisp, this is what we're ultimately essentially creating. Okay, this is obviously, I'm not using command line arguments. I'm not using argv or whatever to actually go and get something from standard in or the command line. This is doing nothing more than just printing a string and then printing a summation. That's leveraging our library. If I want to use this as the entry point to my executable, because the way executables work in Common Lisp is a little bit different than what, let's say, C or C++ does, is while there is a main entry point, what it will first do is it will actually load up the Lisp process, anything that the Lisp virtual, I would probably even call it the Lisp virtual machine when it's starting to compile the code, and then it will go in and call that function. So you're telling Lisp, when you load finally, I need you to execute this function. So that's called the entry point inside ASDF. When we specify entry point here, and we specify our function, let's say that we want to go ahead and compile this guy and make an executable out of this, right? So you might think, okay, when you first do this, and you might think, okay, this is what I have to do. You create something called an operate. You're making a standalone operation. Now, ASDF provides a lot of different things to this operate class. Each task in the build chain is essentially an instance of operation. It's a subclass of operation. So CompileOp is a subclass of operation that has a certain set of methods associated with it. This is what I was talking about, that ASDF does provide an extensible object-oriented protocol and an object-oriented API for you to go and extend the system. And in fact, a lot of the basic build commands that you might use on a day-to-day basis and their convenience functions were built off top of these subclasses of these two main things, operation and component. I won't go into the details of what those two classes actually do today, primarily because it will probably confuse you at this stage. But I am planning on giving an extension to this talk because you should understand how to create your own build tasks in ASDF when you need them. But to call those instances, you would end up using operate, and you specify the operation that you want to actually call. So in this case, we want to call something called ProgramOp, which is essentially telling Common Lisp, hey, I want you to build an executable out of my system. And the component that you specify is going to be the system that you want to actually build. Now, what you might think is when I hit this, it's going to actually go ahead and build and dump out an executable, right? But I just learned this earlier today, and I was surprised by this. But you'll see that when you actually build it, you end up getting an error. And this is because I think that Swank is actually interfering with the dumping of the SBCL image because it's running in multiple threads. And it complains that you're trying to essentially exit out of the program when it's still running a server. So it can't actually dump itself. So what you want to do is here is, and I have obviously a separate shell to show this, is you want to actually go ahead and run this in the shell. And I'm using Roswell for this. I apologize for folks who are expecting SBCL to be doing. Roswell is actually managing all my multiple, Lisps. If we take this command, and we run it here, you will see that, oops, must have done something wrong here. RVUtils does not designate any package. What are you talking about? Must have messed up something here. Oh, that's right. That's why I had it this way originally, because I didn't want to create a separate system definition file. Sorry. Sorry, folks. I forgot that when I moved this package around, that I changed the implicit ordering of the packages because it's no longer that utilities package is no longer available. So let me do this again. You see now when you run the operation, what it's doing is it's literally loading it, compiling everything, loading it up, and it's writing to disk. It's doing what's called a save Lisp and die with some additional arguments. So you might be thinking, oh, and this is on the Mac. I don't know how this would work on Linux. I have to go and double check on it. But you might be thinking, hey, this is going to be located in the directory that the top level directory where the package is located, right? That's actually not true. At least when you're using SBCL, I don't know if it works on, I know it works with SBCL and CCL. When you run anything with ASDF, and you're trying to do a save Lisp and die with ASDF vanilla, what ends up happening is it dumps it into a location called the cache. Now, you can actually figure out where it actually dumped the file to simply by, in SBCL, do the following. You can run ASDF output file. Actually, it'd probably be better if I do it here in Slime. ASDF output file, the operation that you want to do, program op, and then the name of your system. And it will actually specify the location. As you see here, the location is .cache, Common Lisp, the name of our distribution, and then there's this location where the executable is located. So let's go to that. If we do this, go to cache, Common Lisp, SBCL, user data, Roswell, local projects, all that stuff. Okay. You might see that, hey, there's a bunch of stuff here. This is our executable that we just created. But you can also, if you wanted to, create an image off of this. And it's the same idea, actually. It's not that much different. And you will see that I actually did create the same example here with hello ASDF all systems.image. That actually was generated by ASDF itself. And the same operation still applies, actually, which is pretty cool. You're only changing one thing, which is what operation should it actually generate. So let me do this. Let me kill this image. Okay. And you'll see that if you run operate as the image op, this will actually generate, instead of program op, you see your program op, which is generating an executable. This is just generating an image. This does the same thing, and in fact, I'm going to go ahead and do a force all, so it actually goes and recompiles everything. Just to show you that you can actually start from scratch at any point in time you want to, but just running a force all, and we'll go from the beginning. This is kind of like if you're using make systems, it's like if you do a make clean all. So it goes in the order of the tasks that you specified inside the command line. So it first run the clean task and then it runs the all task. By doing a force all, it basically says, okay, I want you to clean everything first and then start from scratch. And what you see here is an image file. Now, if I remember, I think there's a way to load this, but I'm forgetting now how to load images in SBCL. I defer to the documentation on how to load SBCL images. I
think it's --core. I might be wrong though.
SBCL --core.
Yeah.
Hello ASDF all systems. Oh right. Shoot. Oh, not a big deal. I can just go to, where is it? Bin? No, not bin. It was impulse. x86, 64, SBCL bin. Hello. Yeah, bin SBCL.
Yeah, you have to pass a core file.
Yeah. Okay. Yeah. I apologize, folks, but for some reason with Roswell, and I'm still getting used to some of the command line arguments on how to set this up. But there is a way to actually pass in command line arguments with Roswell. But for the time being, I am. Let me see if I can. I'll make a separate video, folks, on how to actually load up core files for you guys, just so that you guys are aware of how to do it. My point still stands that the changing of all it is now for most of the common things that you would normally do building for, like let's say you're building static libraries, you're building DLLs, you're building dilibs, you're building executables and stuff. All that will at the end of the day at some point hit ASDF operate in the particular operation that you're going to call in. There are plenty already predefined operations that are available for you. And if something that is not available, ASDF does provide, like I said, an object-oriented API, and we'll talk a little bit more about that later. But you could also technically define your own operations on your system so that it can actually do other things, like for example, dump out a tar.gz if you really needed to dump out, where your source code is available or not. Let me stop here for a minute and ask, are there questions about ASDF's, at least this basic overview of ASDF?
I'm gonna have to go back and watch this video again, Ron. This is pretty dense for me.
It's probably a little overwhelming. I understand, and there's a lot of material here that which is why I'm trying to take it a step at a time. Because with systems especially, and build systems in general, you have to understand what are tasks and how do they map to the particular tasks. And at least with ASDF, you get some of the most predefined, most normally used tasks for free. This is equivalent to if you use, say, make, which usually has a make command for you to define how to generate compilation. or if you use, say, if you're coming from the node world, I think gulp actually gives you the ability to define tasks the same way too as well, and it has a bunch of predefined tasks that you can leverage. Not to mention, of course, ant, which does the same thing. So this kind of looks like a lot of work for defining our own systems. Is there a better way of actually defining systems? Well, of course there is. You can actually get a template. They'll dump out this guy. And I'm going to show you guys one thing that I've used. It's a project called Quick Project that's from the makers of Quick Lisp, which we're going to be touching base on here. Quick Project essentially generates what you would use for in a typical Lisp project. It leverages a couple of other third-party projects if you want to go and look at the source code, but the main thing that you would want to use here is, if you're running Slime, is Quick Project : make project. And what you could do is you can now specify the location where you're going to host a project. Normally I just do tilde Roswell local projects, and I run it in, let me see, I say test project. And you can now specify, what is the author, Ron Batum. Essentially everything that we actually talked about earlier, description, author, the license, of course. Let's say that this is public domain. What it's dependent on, and usually you use, let's say Alexandria, and it will actually go in and, oops, did I miss one thing? I think I may have messed up one thing. There is, I don't need to actually specify the description. I can only specify the license. Right. So it takes in a couple of things. It can take in the dependencies. It can take in the author, the license that you want to name it after. If you wanted to specify a different path name to the location or copyright, you can also throw that in there as well, and it will generate a test project directory structure for you. So if we go and look into this, let's say that we actually go into the directory, you see it created a markdown README file for the project, a package.lisp where you could define, all your def packages, a top-level Lisp file so you can, obviously start writing your code. And obviously the main thing that I wanted to show you is it'll generate this ASDF def system, the system definition it'll allow you to just adjust. It'll generate, obviously, everything that you specified in the command line plus the order of the code that's already been available. So obviously it doesn't give you everything. Like, you can't take an existing significantly large Lisp project and use this to generate all the ASDs in it. But it'll give you a starting point so that you could quickly get up and running. Especially for newcomers, I think this is probably really great because now you don't have to necessarily remember everything. The only thing I can tell that needs to be dealt with is you have to specify a description inside the ASD after it's been generated versus via make project itself. But we can always extend it and do a pull request so that you can include that information too. Which at this point I think would lead me to, well, this is all nice and great. You have a package. What do we do for distribution? This at this point, I will introduce very briefly what is Quick Lisp. And I think we've talked about it in the past in previous discussions, but we never really discussed what it does. Quick Lisp, much like, virtual env, or actually really it's more like Ruby Gems and pip. It will download your dependencies for you, and in almost all situations, if you're running it at a REPL, Quick Lisp will actually even load them into your running Lisp image so that you can actually leverage them immediately. So like, let's say for example you want to leverage OptiCL, which is an image processing library. It will go ahead and start loading it into your system. It'll grab any dependencies that OptiCL needs to also be loaded to, and it will run essentially the system definition file that OptiCL provided. And the difference is of course, whereas Quick Lisp will actually go and download all the dependencies recursively. If you did this with normal ASDF, every dependency that could not be found in your source registry, Lisp will complain. So this is actually a really nice thing, right? Because now you don't have to you don't have to go into an ASD file to figure out what dependencies a particular project has so that you load them in the right order. You could just say quick load, and it'll take care of that for you. Now, while this is finishing up here, one thing to note is Quick Lisp, it has a couple of convenience functions that allows you to search the registry. By registry, I really mean its package repository. Quick Lisp has its own repository stored on AWS S3. This is where all the curated Lisp files live. So regardless of where you are, geographically speaking, we'll leverage the content distribution network of S3 to get those libraries to you in a timely manner. Of course, it is a curated library, and what I mean by that is you have to essentially submit your intent to actually load onto that project. It's maintained by Zach Bean, and I think his release cycle is he adds new projects once every 6 months?
Monthly.
Yeah, say that again?
Every month.
Every month. Okay, so it's monthly. All right. So that's even better than what I thought it was. Okay. So monthly, Zach Bean will actually update the repositories. So you're almost guaranteed to have very up-to-date libraries. Of course, if you wanted to be on the bleeding edge, that would require you to, of course, run your own distribution server for Quick Lisp, and you can certainly do so. Zach actually even, I remember in one conversation, I think one of his blog posts, I think it was, where he says that he encourages, distributions to have their own distribution-specific repositories. My opinions on that are still on the fence as to whether that's a good idea or not. I will say that if you're doing bleeding edge type of stuff on Lisp, having it is actually kind of an advantage, because then you can still use the same. You can almost think of it as a repository endpoint to get your dependencies, and when they're ready to be shipped, they're available on Quick Lisp. You just point to what I would say is the production Quick Lisp repository to go and download them. Now, one thing that I would like to point out for folks who are new to Quick Lisp is Quick Lisp does have a search engine built in for you to look for libraries. If you know a particular library name or part of a name, it will do a partial match against every file that's available in its registry index, and it will return a list of partial results. So like, let's say that we are looking for LIL, which is the Lisp interface library. This guy actually obviously returns the fact that, oh wait, the latest available project that it has is from April 30th, which is very recent. It also gives you the ability to download its test suite too as well. Let's try, something like WebBlocks. WebBlocks is a web framework for Common Lisp. You can see that, oh man, there's a bunch of different libraries that for the WebBlocks that you can leverage. And you can download what you need from this. It gives you the command. This first column here that I've highlighted represents the package that you would type in when you do quick load.
Not a package.
It's what? Oh, yes, sorry. It's a system. Sorry. I'm sorry. I apologize. Yes, I mean system. It defines the name of the system that you would load when you do quick load. And it will go ahead and, like I said, as it reads it in, it will download the dependencies that it needs to, and it will load them in the sequential fashion that's necessary in order to actually load the library successfully.
Right?
Yeah. Mm-hmm.
Are what it downloads? Are those fossils, or is that raw source, or how is that stuff packaged?
So actually, you can do both. You can specify fossils only. In ASDF, there's a way of actually packaging only fossils. There's a command that I didn't show you here, but I can show you. It's like, I think it's like pre-compiled system. Don't remember the specific name, but if you give me just 1 second, I have it in my notes. Where did I put it? Pre-compiled. There is a way to actually load up fossils, Michael. Here we go. It's called pre-compiled system. So when you def your system, you use what's called a class definition. And this class definition is basically like some predefined object that represents like a sub-package that needs to be available in some extension that has to be loaded. In this case, you're essentially saying pre-compiled system is basically telling Common Lisp that when you load this guy, this is going to be loading a bunch of fossils. So if you type in that will actually go ahead and generate your it'll generate the list of fossils. Like you can specify an expression that will evaluate to a particular fossil or not, and it will load it accordingly. Now, one thing I will point out, all right, there's and this is only because you brought it up. When you build fossils inside Common Lisp, there's two different ways of actually building them. One way is just calling, I think it was libop. And what libop does is it creates a fossil file for each file as part of a package. And the other way is something called monolithic libop. And monolithic, and it's not libop, sorry, it's it is I think it is 1 second. It is monolithic monolithic compile bundle op. That is what creates the fossil file. So you have a single fossil file if you do monolithic compile bundle op. So let me just type this down. So if you say in your ASDF, in your command line, of course I'm going to say this again. I think most of the stuff, with the exception of load op, don't necessarily work inside Slime. If you're doing this vanilla, but if you're doing this on the command line, this should work. So if you're trying to create a fossil type package, you use monolithic, compile bundle op, and this will generate a FASL file for you. Again, mess up something there. Was it? Hold on. It's easier for me to just do this in the shell. Operate. We do CompileOp. So let me start with this pwd. Let me go to the cache, Common Lisp, okay, I want it to be in the directory that we were available in. So let me go ahead and blow away everything that's in this directory, okay? Because I want this to be done from scratch. And if I'm not mistaken, this will create your FASL file. Operate ASDF compile bundle op. If I do this, you can see that if you do an ls on the directory after you quit, it won't quit out of your REPL after you did this, mind you. Okay, it will generate the FASL, and the FASL that it generates is this guy. So now what you could do in your system definition file, you just need to load that, and the way you load it is you can, I think, do like a find system and specify that FASL file, and it will load it up for you. I can after we're done with this, Michael Gargano, what I'll do is I'll actually submit this example in the GitHub repository that you could download and actually work off of. Will that make sense? Will that help you?
Yeah, that's okay. That would be great.
Okay.
I was just kind of curious, like, as to how the stuff in Quick Lisp was actually like distributed, though.
Quick Lisp is like 99 out of 100 times distributed as Lisp files, source files.
Yeah, source files.
Okay, but you can just distribute it as a FASL. Like if there was something that was maybe like proprietary or semi-proprietary or something that people didn't want you necessarily poking around in, or you wouldn't be able to do that at all.
That's a good question. Quick Lisp is actually, I mean, Zach Bean runs his own Quick Lisp repository, but nothing is stopping you from running your own, where you can have your own rules. I'm not sure exactly what Zach's rules are as far as open sourceness and everything like that. I know he requires that it must build on SBCL, and it must be it must make an effort to at least run in other distributions or implementations, but he doesn't test on them, as far as I know. As long as it's, it has a license specified in the ASD file, and it compiles and loads on SBCL, it's game for Zach Bean's repository, but you can run your own repository. Quick Lisp doesn't prevent you from doing, running anything of your own.
Gotcha.
You semi-FASL, semi-proprietary libraries, the infrastructure that Zach Bean provides in Quick Lisp doesn't prevent you from doing that, and ASDF doesn't prevent you from doing that. Now, Quick Lisp itself, like in terms of his specific repository, I think, as Michael Fiano pointed out rightly, the majority of that code is open source. So when you download a file, and I can just show this to you, like if you go into where it downloads it, so like let me do this. Let me clear up some of these windows here. So if you go to where it downloads all your third-party libraries, so like in Roswell, it was what source it was? Lisp, Quick Lisp.
Dists.
This, yeah, Quick Lisp software. So now in here you'll see all the source code for like every library that I've ever downloaded. So like let's take Sketch for example. This is the state of Sketch as of November 30th, 2017. So you can actually go in and actually read through some of the files there if you wanted to. It's a good way as you're navigating through this code, the source code, and especially when it comes to ASDF, you can see how certain people did things. Like McClim is probably the example Lisp system I tend to like try and grab stuff off of, just because there's a lot of multiple subsystems with McClim, the Common Lisp Interface Manager. So it actually shows you how they sort of interact and where at what size should you go and say, okay, I need to split this off into a separate ASD file, because it's getting too big. Because they've actually broken it apart based on operating system, based on use, and based on particular module that need to be loaded. That is one thing that I wanted to point out too as well. Much like make files, having make with submakes and different make files with a directory hierarchy, you could do the same thing in ASDF too as well. I didn't show it to you just because I thought that would kind of be a little bit overwhelming, but it certainly is a feature that is available. And when we get into some actual case studies, I think it'll be prudent for us to actually revisit how to generate that, because it will be especially helpful when you want to like create a combo client-server application that, based on how the command line, the executable is run, what libraries need to be available and what needs to actually get loaded would become useful. So that's it for all I have for now. Are there questions? Other questions? Judd, are you completely confused, or are you just?
I'm not confused, but I'm gonna have to go back through this. This is very dense. So this is very good, Ron, and I think it'll be kind of a reference. But yeah, there's a lot here.
Michael Fiano, do you have any final thoughts to add? Like anything that I've missed?
No, I think you did a pretty good overview of ASDF. However, I will say that for beginners or intermediate users, you hardly ever need to use ASDF. Usually you just use Quick Lisp, one command, quick load, or the appropriate search, as Ram pointed out, and those will do everything behind the scenes as far as loading software and searching for software. You normally don't ever have to use ASDF by itself.
Right.
And that's probably where a lot of your confusion lies, is in all those examples Ram provided. But that's if you want to do complex stuff like make files, like Ram was pointing out.
Build systems is a very difficult beast to talk about. And what I will be talking to you, hopefully, if I can get through some of the examples in a decent way, because the documentation is still a little bit sparse, it is my hope that there's another approach that one could do to actually building your application, and that is through this fairly new utility that came out, and that is what I was showing you earlier, which is Roswell. Roswell gives you the ability to actually create a single script, if you will, and if you specify a command like RosBuild, based on how you set it up, it will actually go and build the software for you. Now, it doesn't make you escape ASDF at all completely, because you still have to work with ASDF in order to specify your build systems, especially for libraries. But for standalone executables and things like this, I tend to use it. It's great for one-off scripts too as well, if you want to create scripts that you want to build and run. It's also a way to actually build and run scripts as if they were shell scripts. So that is, though, that's a different discussion, though, because it's a fairly involved topic. But I hope at the end of the day, the folks that are watching this, you get a sense that you can actually do a lot of stuff in Common Lisp that you could also build off of. For example, if you wanted to, and I will try and go through an example of this in a different episode, compile an executable in a Lisp and then copy it to a Docker file, much like you would do if you were doing Go. Instead of actually loading up a Go executable, you load up a Lisp executable and throw it up on your cloud platform of choice, and it'll work the same way. There are plenty of ways of doing this, plenty of examples that we can go through, but we're running out of time. So I really don't want to start down the path of running through a completely different example. But next time we'll be touching a little bit more on Quick Lisp, because I think it is important for you guys to really know what Quick Lisp provides. And especially the folks of you, who are doing semi-proprietary stuff, where you can't actually distribute your libraries. In that situation, I'll try and show you how to run your own Quick Lisp repository, and hopefully that will help you folks to at least know where to draw the balance. I have some opinions on that, but that's for a different time. Any other comments from my dedicated folks in the study group?
I'm good, thank you.
Cool. Well, until next time, thanks for joining us. I'm your host, Ram Vedam, signing off. See ya.